Hi, today we are going to learn about a doll starter with intelligent motor controller. Let's see how this starter looks like. This is the scheme drawing for a doll starter with intelligent motor controller. So this box, this is called the intelligent motor controller diagram. So here it is LTMR. LTMR is from Schneider Electric. There are other intelligent motor controller as well from ABB and Siemens. Now let us understand the fundamentals. Like this portion again, the left side is the power circuit, and the right side, this side is the control circuit, right? So the power circuit, this one is 415 volt, and this control circuit you can see it's a 230 volt AC, and here also it is a 230 volt AC. So this is UPS supply and this is non-UPS supply. The UPS supply is provided to the controller directly because it needs a raw and stable power. Also, this power is supposed to be remain there even in case of power failure. And this is a non-UPS supply because this supply is going to the field. When I am saying to the field, it means it is going to the LPBS. LPBS is local push button station. Local push button station is a box which generally installed very near to the motor. Now the power is that from the bus bar. This bus bar is the MCC to the SFU switch fuse unit. This is kept here to prevent the short circuit fault, and then the line is passed through the cities of LTMR. So it is not shown here, it is never shown in anywhere, but there are inbuilt cities in LTMR through which it is passing. Then there is the power contactor, and after that the power is going to the motor. So if I need to supply power to the motor, that is to run the motor, we need to close this contact C. Now this single phase SPP, single phase protection relay, what happen is that LTMR comes with lot of protection, and let me show you this. Let me show you this. This is a catalog. I was just checking for LTMR. See, this is the LTMR T60 24 volt, and this is the protection type. In this, there are thermal protection, load fluctuation protection, power factor variation, phase overload, phase failure, overload, reverse polarity protection, overload long time, earth leakage protection, lock rotor protection, thermal overload protection, and phase unbalance protection. All these are given. So out of that, this phase failure protection is the same thing as single phase preventing uh, relay. So now again, so this single phase prevention relay, SPP relay, single phase prevention protection, is actually not required because this same protection as a phase failure is given in the LTMR. Exactly, this is what as a design engineer we need to suggest our client to save their cost. Let's say this relay, if it is cost even maybe 10,000, 15,000, and there are hundred of doll type feeders, then 10,000 into 100, it means 10 lakh rupees. which can be saved, which is a value engineering done by the design engineer. These are the things one need to check while designing the circuits. Now in the LTMR there are six input. LTMR is something like a PLC. It's a kind of a micro PLC where you have certain inputs and you have certain outputs. So in LTMR there are six inputs like 6 DI, and there are three output like 3 DO. Apart from that there are two fault output, one NO and one NC. This one is NO and this one is NC. These are the things. I mean, these fault contacts cannot be programmed, but this DI and this DO can be programmed. Now let us understand how this operates. So if I want to start this motor, I have one option is starting it from the local push button station. How it will work? Let's say how the power will be supplied up to this local push button station. So the non-UPS power is coming through this. So this dotted line means that it is mechanically connected to the SFU unit. If the SFU unit is switched off, so there will be this will be open and there will be no power to the control circuit. After that, this SPP fault if there, then also there will be no power to the control circuit. Then there is a stop push button which is on the MCC. If somebody press it, then also there will be no power. Then LTMR, this is LTMR fault. If there is any fault from LTMR, then also it will not work. The power will not be there. This is future interconnection. This is a very important thing because as a designer, if we are missing something, then that can be incorporated later on at the site without much hassle. Otherwise, this wiring to be done at site level, which is a very tedious task to do. After that, the power is supplied to this start push button, right? Now, if you press this start push button, the power will go to R3, that is a local start. This R3 is again connected here as a input to this DI to the LTMR. After this, inside there can be certain programmings which may check some other faults and which is like as I show that there are a lot of protections given. If no faults are there, then it will provide an output which will energize this R1 relay, and this R1 have a contact here which in turn will energize this contactor C, which means this C have contacts which is connected to the power line, and then the power will be supplied to the motor. This is how it is going to be started. Now let us look how it can be stopped. So this is the power line. This is the source of the power line. If we can simply disconnect it, if we can simply disconnect it, then only it will stop, right? So one stop is put here. So in front of MCC there is a stop push button. If anyone press this push button, this power line will be disconnected. This line, this line, right? So it will stop. And the second option is emergency stop push button, which is in the LPBS. If someone press this push button, then this R1 gets deactivated. It's a reverse logic. This is also called a fail-safe logic. So when it fails, it is safe. That's the concept. So once R4 is de-energized, R4 is connected here. So this will also get de-energized, which means that this signal will show it is as a zero input. Then we can program here inside this. Thus, if we get a zero here, then we'll de-energize this output R1. When this output R1 will get de-energized, this contact R1 will open and this will de-energize the contactor C, which means these contacts will open and no power will be there in the motor. That's how it can be stopped. Other than these, what we need to look into is that these are the terminals X2, sorry, X2, X3, and X1. X1 is a power terminal. See, it is written here as 415-volt AC power supply to the motor. So RYB, and this is the RYB, right? This is the power terminal, and these are all control terminals. So we need to understand wherever these, as I told even in the other videos as well, this type of terminal symbols mentioned, these are the symbols which indicates that connections somewhere from the outside of the panel is coming into this panel here, and those terminals are mentioned here. This is the way it is to be represented in a drawing, that which are the terminals are connected to outside of this MCC, and what are those signals. For example, this is future on interlock, this is pair terminal, this is 2 LPBS, this is thermistor, or it is from thermistor, rather, thermistor of the motor. So this is how the DOL circuit operates in a intelligent motor controller, and these are the things we need to look into. Okay, I have one question for you. If you are watching this video, just comment me, what is this thing, what is this symbol, and why it is connected here. That is one question. And second question is that why this R1 is separately taken? Because we could directly energize this C rather than energizing this R1. Why it is taken as R1 and then the contact of R1 is kept in this? So these are the two questions. Please comment um, comment on this video. Let me check your understanding as well. So this is all. Thank you. Hope this video was useful to you.